Hello my dear students, I hope you're all doing well. My name is Menathan Patan and I welcome you all to the channel Classroom where we learn together. So, my dear students, our topic for today is oxidation and reduction. Now this is an easy topic, so I am sure you must have understood from your classroom explanation given by your class teacher, your subject teacher. Now, but if you're here, that means you want to learn more. Okay, so yes, here I will teach oxidation and reduction. I will try to teach in such a way that it will strengthen your existing memory. And to those students who did not understand quite much from the school, from the class teacher, from your subject teacher at school, now I will make sure that this is sufficient for you. So I'll be giving my very best, my 110% to make it easy and to make it like fun as well as understanding and so that it will help you understand and you will not forget. So my goal is to make sure that you understand and you score good marks. Okay, so this lesson is very important, plus it is also very easy. And in today's video we will be discussing about besides this oxidation and reduction, we'll be discussing about oxidizing agent, then reducing agent, then types of redox reaction. Okay, and with that we will wrap up the lesson. So chapter 1 will come to an end with today's video. Okay, so the videos on the previous topics have been uploaded, so in case you have missed out, do kindly check it. Okay, check the videos and do let me know your valuable comments. So do let me know whether you liked it or not. Okay, so I need your support, so please continue your support and show your love. All right, so now let's start the lesson. But before I go and I pick my marker, one thing which I always tell you all, my dear students, is that when you watch this video, I want you to grab your notebook, a pen or a pencil, and take down the notes. Okay, let it serve as an additional notes so that it will help you score better in your exam. Okay, so we will write down. I will write down here and you will write down from your end in your notebook. Deal? All right, so let's start the class now. So the first thing that we will be discussing will be the definition of oxidation and reduction. So oxidation and reduction can be defined with respect to gain and with respect to loss. We can define oxidation and reduction with respect to gain and loss. So let's do that. So let me split the page from here and write here oxidation and let me write here reduction. Let's first define with respect to gain. So with respect to gain, or we can also say addition. Gain and addition are same. So what is oxidation with respect to gain? Oxidation with respect to gain is those chemical reactions where oxygen is gained. So chemical reactions where oxygen is gained or we can or added. This is the definition of oxidation in terms of gain. Now let's define reduction in terms of gain or addition. Then, if oxidation are those chemical reactions where oxygen is gained, then reduction are those chemical reactions where hydrogen is gained. Okay, so chemical reactions where hydrogen is gained. or added. So reduction, the definition of reduction in terms of gain are those chemical reactions where hydrogen is gained. So hydrogen is gained in reduction, whereas in oxidation, oxygen is gained. Now we will define oxidation and reduction with respect to loss. So with respect to loss, or we can also say removal, no? Yes. Yes, removal. REMOVAL. So loss means removal only. So with respect to loss, what will be the definition of oxidation? With respect to loss, oxidation will be those chemical reactions where hydrogen is lost. So chemical reactions where hydrogen is lost. Hydrogen is lost or removed. Then with respect to loss or removal, what will be reduction? What will be the definition of reduction with respect to loss or removal? With respect to loss or removal, reduction are those chemical reactions where oxygen is removed. Okay, so chemical reactions where oxygen is removed. Or yes, remove or loss isn't the same. Remove, loss, remove. Let me just write it here. Complete it. So this is the definition of oxidation and reduction with respect to gain and with respect to loss. So kindly take down this. You can pause the video and you can copy down the definition. Okay, now, so oxidation. What is oxidation? Oxidation are those chemical reactions where what are we gaining? We are gaining oxygen. But at the same time, we are also losing something. What are we losing? Hydrogen. So we gain oxygen and we lose what? Hydrogen, isn't it? Now let's go to reduction. Reduction are those chemical reactions where we gain. What are we gaining in reduction? We are gaining. Are we gaining oxygen? No. Oxygen we have gained in oxidation, isn't it? So in reduction, what are we gaining? We are gaining, yes, hydrogen. We gain hydrogen. Then what are we losing? We are losing oxygen. We gain hydrogen, we lose. If we gain hydrogen, we lose oxygen. Okay. And if we gain oxygen, what are we losing? Hydrogen. Okay. So you have to remember this. You have to remember this. It's not difficult. It's easy. It's very easy to remember. Now we will do some examples. And with the examples, I guarantee you that it will become very easy again. So let's do some examples here. So let's take some examples. The examples will be taken from your textbook. So the first example is CuO plus H2 undergoes chemical reaction, and then we get Cu plus H2O. Let's study this chemical reaction and understand oxidation and reduction in detail. So let's first observe these chemical reactions. So we have the reactants here, and we have, these are the products, correct? Arrow indicates that chemical reaction has taken place. Now, how many reactants we have? 2 reactants we have. How many products we have? 2 products we have. Is this an elementary compound? Yes, this is a compound. Elementary compound, element. Elementary compound, element. Elementary compound, compound. Now, to study oxidation and reduction, my dear students, you have to do one thing. There is something that you have to do, and that is you have to create a link. So you have to create a link. So let me show you how to create a link. So how do we create a link? To create a link, what you have to do is always start from the first reactant. So this is the first reactant, and this reactant is a compound. Okay, this is a compound. So if the reactant is a compound, start with the first element. So this is the element. So focus on this element, which is copper. And now this is the reactant side, isn't it? So from the reactant side, you are focusing on this element. Now focus on the same element from the product side. So this is copper. So we are looking for copper there. Do we see copper there? Yes. So this. So we have copper here from the reactant side, and we have copper here from the product side. We have to create a link. So let's create a link. So by link, I mean this one. This is what is called a link. So this is called a link. Okay. This is what you have to learn. Okay. This is what you have to learn. While studying oxidation and reduction, this is very important because this will tell a story of what is happening here. Is it oxidation or is it reduction? It is very important to draw this link. Okay, because this helps to narrate the story of what is happening here. So now that we have created a link, let's understand, okay, what is going on here. So let's understand what is going on here. I see copper here, I see copper here. All right, that's why we have created the link, isn't it? Now this is copper oxide, whereas this is copper. Copper oxide, copper. Tell me what is going on. Copper with oxygen, only copper. Can we say that copper has lost oxygen? Can we say that copper has lost oxygen here? Yes. So copper has lost oxygen. Tell me, where is losing of oxygen happening? Is it in oxidation or is it in reduction? It is in reduction, isn't it? Oxygen is removed. Oxygen is lost. So what is happening here? Copper oxide undergoes reduction. So here reduction is happening. So this is a reduction reaction. This is a reduction reaction. Okay. Now we'll go to the next link. Okay, we will create two links because we are studying oxidation and reduction. So we will create two links. So now we are done with the first reactant. Now we have another reactant. So focus here. Okay, so we'll focus on this one. So this is the second reactant, and this is an element. So we know that the link will start from him. Okay, and then what are we doing? We are looking for the same element on the product side. Do we see hydrogen there? Yes, this is the hydrogen. So we know that this is the link. So just draw the arrow here. So you have established the link. Now let's try to understand what is happening here. What is the story here? This is hydrogen. Hydrogen, water. Hydrogen, water. Hydrogen becomes water by gaining oxygen, isn't it? See, hydrogen is not alone now. Hydrogen is with what? With oxygen. So hydrogen and oxygen together. So can we say that hydrogen has gained oxygen? Can we say that hydrogen has gained oxygen? Yes. Hydrogen has gained oxygen. So hydrogen has gained oxygen. Gaining of oxygen. Gaining of oxygen happens at oxidation or reduction? Yes, it happens at oxidation. So this hydrogen undergoes oxidation. So this is a story of oxidation. So this is a story of oxidation. So this is oxidation happening. Easy? You tell me, is it difficult? No, isn't it? Okay, so what is happening here? CuO is reduced to Cu, and then hydrogen H2 is oxidized to water. So this is what is happening here. All right, now let's take another example and let's study again. So let's take the second example and let's do this together. So the second example will be again taken from your textbook. It's MnO2 plus what is the other one? MnO2 plus HCl. So HCl, this is the arrow which indicates that the chemical reaction has taken place, and the products are manganese chloride plus water plus chlorine. Now let's do this together. I need your help here, so we'll do this together. Okay, so now let's start. So the rules remain the same. How many reactants we have? Reactant number 1, reactant number 2. So we have 2 reactants. How many products do we have? 1, 2, 3. Will this be a problem, having an uneven number of reactants and products? No. Okay, no, it will not cause a problem. We have 2 reactants. Okay, so we will start with the first reactant. the first reactant is a compound. Well, even in the previous example, it was a compound, so we know how to do. So what do? We will focus on the first element, which is manganese. So manganese is here. Now we will be going to the other side, which is the product side, and we will search for manganese. Do we see manganese on the product side? Yes. Where is it? It's there. It's here. So manganese here, manganese here. Link. Create a link. So create a link. You have just created a link. Very good. Very good. See? It's very easy. Then, now let's write down the story. What is the story here? We have manganese oxide, and this is manganese chloride. Something has happened. What has happened? Manganese oxide becomes manganese chloride. Something has happened, isn't it? Excuse me. What has happened? See, we don't see this oxygen here anymore. We don't see this oxygen here anymore. So can we say that manganese has lost oxygen? Yes. So manganese loses oxygen. Where is losing of oxygen? Is it in oxidation or reduction? It's in reduction. Sorry, it's in reduction. Okay. So this is reduction. So this is reduction. Easy. Next, we go to the second reactant. So now, this time the second reactant is also a compound. Well, we have done two compounds. Okay, and we can do so. This will not cause any problem. This is a compound. We know what we have to do. We will start from the first element. So we will start from hydrogen, and then I'll be searching for hydrogen from the product side. I see hydrogen there. This is the hydrogen. So this is how you create a link. So यहाँ से all the way to here. This is how you create a link. Easy, very, very easy. So let's narrate what is going on here. This is hydrogen with chlorine, and this is now hydrogen with oxygen. Hydrogen with chlorine, here hydrogen with oxygen. Something has happened. Tell me what has happened. Please tell me what has happened. Yes, hydrogen gains oxygen, isn't it? Hydrogen gains oxygen. Here it was hydrogen with chlorine. Now if you go to the product side, you don't see chlorine. Rather, instead of chlorine, we see oxygen. So hydrogen has gained oxygen. So what is this? This is a case of reduction or oxidation. Please tell me, is it reduction or oxidation? Yes, it is a case of oxidation. Okay, so this is a case of oxidation. So that's it. How easy is this? See, it's very easy. Okay, it's very easy. Now, okay, so let's write down what is happening here. So what is happening here? MnO2 is reduced to, what is it reduced to? MnO2 is reduced to MnCl2. MnCl2. Then what about HCl? HCl is oxidized, isn't it? Oxidized to water, H₂O. So this is oxidation and reduction. Okay, so please copy it down. I'm moving it to the side so that the screen becomes visible to you. Okay, oh, the screen is visible so that I'm not blocking the write-up. Okay, so now let's erase some and let's go to the next topic, which is let's talk about oxidizing agent and reducing agent. So our next topic is oxidizing agent and reducing agent. Let's understand what an oxidizing agent is and what a reducing agent is. Okay, so oxidizing agent, let me write in bold letter. Oxidizing agent and then reducing agent. So who is an oxidizing agent, or what is an oxidizing agent? See, the substance that gets reduced is called the oxidizing agent. The substance which gets reduced in any chemical reaction is the oxidizing agent. Okay, so it is the substance that gets reduced. The substance that or which that gets reduced. Oxidizing agent is the substance that gets reduced. All right, then who is the reducing agent? It is a substance that gets, fill up and tell me. You can fill it up. If oxidizing agent is a substance that gets reduced, then reducing agent is a substance that gets, see, you know the answer. Yes, you're correct. It's the substance that gets oxidized. Okay, how easy is that? Full stop. Okay, so it's very easy. Now let's check whether we have actually understood or not. Okay, so let's identify the oxidizing agent and the reducing agent from the given two examples. So let's first start with oxidizing agent. Let us identify the oxidizing agent from the two chemical reactions. So who is the oxidizing agent? The oxidizing agent is a substance that gets reduced. So the substance which undergoes reduction becomes the oxidizing agent. Isn't it? It's quite the opposite, isn't it? The substance that undergoes, okay, the substance that gets reduced is the oxidizing agent, whereas the substance that gets oxidized is the reducing agent. Okay, so there is a possibility that you get confused. Okay, so keep revising. Okay, make sure that you revise often. Okay, now let's go here and then let's learn for once and all. Okay, like what oxidizing agent is and what reducing agent is. Okay, so let's start with oxidizing agent, the substance that gets reduced. So if we look at the first example, copper oxide. Okay, copper oxide undergoes reduction. So copper oxide undergoes reduction. So the substance which undergoes reduction, okay, the substance that gets reduced is the oxidizing agent. So copper oxide is the oxidizing agent. So this is the oxidizing agent. Oxidizing agent. Then let's identify the reducing agent from this example. So the substance that gets oxidized, hydrogen gets oxidized, so hydrogen is the reducing agent. So this is the reducing agent. Confusing? Is it confusing? No. Okay, it's not confusing. Let's do the next example. So let's go to the second example. So let's identify the oxidizing agent. So if it is oxidizing agent, where are we going? We are going to reduction. Okay, so oxidizing agent, the substance that gets reduced. So here MnO2 gets reduced. So this is the oxidizing agent. So this is the oxidizing agent. And then reducing agent, the substance that undergoes oxidation is the reducing agent. So HCl undergoes, okay, HCl undergoes oxidation. So HCl is the reducing agent. So that's it. Now you are clear with oxidizing agent and reducing agent. I hope you understood. All right. So now let's discuss the next topic, which is redox reaction. So let's study redox reaction. Redox reaction or reactions. So what are redox reaction, or what is a redox reaction? So the definition of redox reaction is chemical reactions in which both oxidation, okay, and reduction takes place simultaneously are called redox reactions. Let's write down the definition. So, chemical reactions in which both oxidation and reduction takes place are called redox reactions. So, chemical reactions in which both oxidation and reduction takes place simultaneously are called redox reactions. Takes place simultaneously. Let's put the word simultaneously here. Simultaneously means in the same chemical reaction. So now let's have a look at this chemical reaction. Can we say that this is an example of redox reaction? Can we? Now, in order for this to be a redox reaction, it has to have both oxidation and reduction. Do we have both oxidation and reduction happening in the same chemical reaction? Yes. So this is an example of redox reaction. Okay. What about the second example? You tell me. What about the second example? Is the second example an example of redox reaction? What do you say? Yes or no? How many for yes? Raise your hand. Yes. How many for no? Okay. I don't see any hand for no. Most of you, I saw most of you raising for yes. So yes, you're correct. So the second example is also an example of redox reaction. Why? Because we have both oxidation and reduction happening in the same chemical reaction. So remember, class, that redox reactions are those chemical reactions where both oxidation and reduction are happening simultaneously. Okay, so one chemical reaction where both oxidation and reduction happens is called redox reaction. Are we clear? All right. So now let's erase the entire thing and let's go to the next topic, which is types of redox reaction. So let's go to the next topic, types of redox reaction. So let me quickly erase this and make room for the next discussion, which is types of redox reaction. Let me use this cloth now. Keeping the whiteboard white is a challenge. It's not easy. The duster gets the black stains, and after which rubbing it with the black duster makes the whiteboard makes the whiteboard blackish again. So I have to use a cloth here. All right, I hope that's visible enough. Okay, so let's discuss the next topic, types of redox reaction. So let me write down here, types of redox reaction. So there are two types of redox reaction mentioned in your syllabus. The first one is rancidity and the second one is corrosion. Now, we don't need to go very deep into it, so I will not be going very deep. I'll be telling you everything which you need to know about both rancidity and corrosion. So let's first start with rancidity. So the first will be rancidity. Let's talk about rancidity. So, what is rancidity? My dear class, rancidity simply means oxidation of food items. Okay, I repeat, oxidation of food items is called rancidity. Oxidation of food items which are prepared in fats or oil is called rancidity. Alright, this is the simplest definition of rancidity. Oxidation of foods prepared in fats or oil is called rancidity. What actually is rancidity? Rancidity is where the food develops a foul smell and the taste also becomes bad. this phenomenon, okay, which mostly happens to fried foods which are prepared in oil, okay, this phenomenon is called rancidity. So remember, rancidity is oxidation of food. Understood? Rancidity is oxidation of foods which are prepared in oil. What actually happens in rancidity is that their smell changes and their taste also changes. Okay, their taste becomes bad and their smell also becomes foul or bad. Okay, so let's write down the definition of rancidity. So the definition is oxidation of oil or fat containing food items resulting in bad smell or taste is called rancidity. It's called rancidity, or it is also known as rancidification. Rancidification. So this is the definition of rancidity. Okay, oxidation of oil or fat containing food items resulting in bad smell or taste is called rancidity or rancidification. So the samosa which you forgot to eat and you kept it, okay, out, okay, you kept it in the bowl and you remembered that you had kept the samosa after a week, and when you go, okay, to eat it, the bad smell and the foul smell and the bad taste which the samosa has developed is what we call rancidity. All right, so what will you do with the samosa? Will you eat it? No, throw it. Okay, you better throw it, unless you want food poisoning, because consuming such spoiled foods will lead to food poisoning. So we are not supposed to eat that. Okay, so don't consume spoiled foods because it will give you food poisoning. So now let's so now, is rancidity good? That is my question to you. Is rancidity good, class? Yes. The answer is no. Okay, the answer is no. Okay, the answer is no. Rancidity is bad. So since rancidity is bad, should we prevent rancidity? Are there ways by which we can prevent rancidity? The answer is yes, and that's what we will be discussing. So let's study some ways by which we can prevent rancidity, because rancidity is bad. So ways to prevent rancidity. Ways to prevent rancidity. So how can we prevent rancidity? Number one, we can prevent rancidity by addition of antioxidants. So addition of antioxidants, addition of antioxidants. By adding antioxidants, we can prevent rancidity. Now, I know what you want to know. There's a question in your mind. Sir, what are antioxidants? So what are antioxidants? Good question. So antioxidants, see, anti means oppose. So antioxidants are those substances which fights back against oxidation. Okay, so they are called antioxidants. There are some substances which fights against oxidation. They are called as antioxidants. Examples of antioxidants are vitamin C and vitamin E. Okay, so examples of antioxidants are like vitamin C, and vitamin E. So vitamin C and vitamin E are examples of antioxidants. So if we put them, okay, while preparing the food items, then the food items will be able to fight against rancidity. I hope that's clear. Now let's go to the second point. It is filling in with nitrogen or helium gas. The second way to prevent rancidity is filling in with nitrogen or helium gas. Now, what does it mean? First of all, let me tell you that this method is used in chips manufacturing. Method is used by chips manufacturers. Okay, so we are all familiar with chips, isn't it? CHIPS. We are all familiar with chips. I am fond of chips. Okay, I like chips. So when I say chips, we are talking about Uncle Chips, Lay's. Okay, those fried potatoes which are sold in the shops. Okay, so chips, they are made from, well, since I eat Lay's, I know that Lay's is made of potato, and then the Lay's is fried in oil. Okay, the Lay's is fried in oil, and then it has got a good smell and has got a good taste. So that's how the companies make it, and that's how I get it also. Now the company is far away there, some hundreds and hundreds of kilometers away. I reside in Kohima, Nagaland, and I know for sure that it's not made in Kohima, Nagaland. It's made somewhere in some of the states. Okay, some of the states, not here. So far away from there, it reaches me here, and I still get to enjoy the crispy taste and the sweet smell. Whereas the chips is fried in oil. Here, I am not able to keep the samosa for a week. Okay, I am not able to keep the samosa for a week because it becomes rancid. And there, the chips, which was prepared 3-4 months ago, I still get to eat. It's crispy and it has got this refined taste. How so? It's because the companies are filling in the chips packets with nitrogen or helium. Okay, so chips are fried potatoes, and since they are fried in oil, rancidity will take place, isn't it? So the food will react with oxygen, and then it will become rancid, by which the smell will become bad and the taste will also become bad. But it's not happening so with chips. Rather, the chips, they are able to retain their good smell and their refined taste. How so? It's because the chips manufacturers, they fill in the chips packets with helium or nitrogen gas. Okay, they are not filling in with oxygen. If they fill in with oxygen, then the chips will become rancid. So by the time it reaches you, it will have a bad smell and a bad taste. But since they fill in with nitrogen or helium, the chips are able to retain their crispiness and their good smell. Now, how are they able to do so? These two gases are able to do so because of their nature, which is inert. These two gases are inert in nature. Inert means not reactive. They do not react with the chips. Okay, they do not react with the chips. Thereby, the chips are able to retain their crispiness and their good smell. Okay, so I hope you understood why when you go to the shop and you ask for a chips packet, you will always get it puffed. It's puffed because the companies have filled in with nitrogen or helium, so that the chips, okay, they do not undergo rancidity, and also so that you get to enjoy the chips, and also so that you get to eat more chips. Okay, so that you get to eat more chips. But remember, top priority should be food. Okay, always give top priority to food, and a little bit of snacks here and there. Okay, it's all right, but don't compromise your food. Food is major. Okay, your food is the most balanced diet, so you have to always eat food. Understood? Next, number 3 is refrigeration of food. Refrigeration of food. Now, why do we keep food inside the refrigerator? Why don't we just keep it outside? See, we don't keep it outside because if we keep it outside, then rancidity will take place. The food will react with oxygen present in the atmosphere, and then the food will become rancid. The food will become rancid, and we don't like to consume rancid food. So what we do is, we can keep, then how do we prevent rancidity of food? We can keep the food inside the fridge, inside the refrigerator, or inside the cold chamber. Okay, now, does it help? By keeping the food inside the refrigerator, does it help fight against rancidity? The answer is, see, by keeping the food inside the refrigerator or inside the cold storage, what happens is that we are able to decrease the rate of rancidity. So keeping the food inside the refrigerator is not a complete solution for rancidity, but it will help decrease. Okay, it will help slow down the rate of rancidity. Understood? So keeping the food in refrigerator or inside the cold storage helps slow down the rate of rancidity. Remember, the food will become rancid eventually if you keep inside the refrigerator for months and months. The samosa will become rancid, no doubt. Okay, but here you have kept it for months and months. Whereas if had you kept it open in the table, then it will take you within 2 days. It will become rancid in summer. Okay, in summer though, not even 2 days. Okay, in summer though, within hours it will become rancid. All right, so it's faster. Food becomes rancid faster in hot environment, and this is also the reason why we keep food inside the refrigerator. Because if the environment is hot, then food spoils faster in hot environment than in cold environment. So for this very reason, we keep food in cold environment, because if we keep the food in cold environment, the rate of rancidity, the speed at which rancidity takes place becomes slower. So rancidity happens at a slower rate, thereby the shelf life of the food increases. Okay, so remember, we can keep the food inside the refrigerator and slow down the rate of rancidity, and then we can make the food last for longer hours or longer duration of time. All right, so these 3 methods we can apply. These 3 ways, by applying these 3 methods, we can prevent rancidity. I hope that's clear. All right, so now let me erase this and let's go to the last topic, which is corrosion. So we'll discuss corrosion now. So the last topic, which is corrosion, CORROSION. What is corrosion? So let's try to define what corrosion is. So my dear students, corrosion. The definition of corrosion goes like this. The process of conversion of a metal to its oxide, sulfide, or hydroxide form is called corrosion. Let's write it down. Okay. So the process of conversion of a metal to its oxide, sulfide, or hydroxide form is called corrosion. So corrosion is the process by which a metal is converted to its oxide, sulfide, or hydroxide form. Okay, and remember this, my dear students, that corrosion is a surface deterioration process. So you can write as a note that corrosion is a surface deterioration, DETERIORATION process. So corrosion is a surface deterioration process. What does it mean? Corrosion is a surface deterioration process. It means that corrosion starts from the outer surface. Okay, corrosion attacks the surface of the metal. Corrosion happens from the surface of the metal. Understood? So this is what it means, that corrosion is a surface deterioration process, means it attacks the surface first. I hope that's clear. So now let's understand corrosion a little deeper by discussing corrosion with respect to 3 metals. First we'll discuss with iron, then we'll go to silver, and copper. Okay, so we'll start with iron first. So iron, let's understand the corrosion of iron. Now, iron is one of the most reactive metals. Now, iron being reactive, it reacts with oxygen and moisture, which means water present in the atmosphere. So let's say this is the iron. So this is the iron, a brand new iron. Now remember, iron when it is new has got its own luster, has got its own shine and color. What is the color of iron when it is new? Iron, the color of iron is grayish. It has got a metallic gray color and it has got a good shine. Okay. Now this iron, what happens is that it will react with oxygen and moisture. Moisture means water present in the atmosphere. Okay, and then it undergoes corrosion. CuRROSION. It undergoes corrosion. Now, when iron undergoes corrosion, what happens is that the outer surface of the iron, okay, will start forming a deposition. So the when iron undergoes corrosion, then a reddish brownish flaky coating is developed on the outer surface of iron. So this is the same iron. So let's say this is the iron. Then what will happen to this iron is that on the outer surface of the iron, a reddish brownish flaky coating will take place. So let us, since it happens on the outermost surface, so let me draw something like this. Okay, and then on the outer surface, so let this one, I'm shading it. So this will be the reddish brownish coating, which is flaky in nature. So what is this? This one, the black highlight which I have done is the reddish brownish flaky coating. So on the outer surface of the iron, a reddish brownish flaky coating is formed. This reddish brownish flaky coating is also called as rust. I am sure you must have heard this name rust a lot. Okay, so what is rust? Rust is simply the reddish brownish flaky coating which is deposited on the outer surface of iron when iron undergoes corrosion. So when iron reacts with oxygen and moisture present in the atmosphere, it undergoes corrosion, and then when iron undergoes corrosion, a reddish brownish flaky coating is formed over its surface. This reddish brownish flaky coating is called rust. I hope that's clear. Now, so this iron becomes like this. So this is rust. Now, since this coating is flaky, that means it can be peeled off. It can come out. Okay, so it can be removed. So this gets peeled off. Since it is flaky in nature, so this coating which is deposited, it will peel off in due course of time, and then what happens? A fresh layer of iron will be exposed again. Okay, so a fresh layer of iron will be exposed, and then the same coating will take place on the fresh layer of iron, and then now again here corrosion will take place. So rusting will happen here. So the reddish brownish coating will be formed again here. Okay, on this new exposed layer, and then what will happen? After some time, this layer will again peel off. This layer will again come out due to wear and tear or mechanical action, and finally a new layer will be exposed again, and again on this new exposed layer, again what will happen? Rusting will take place. So the flaky coating, the reddish brownish flaky coating deposition will take place here, and I hope you are getting what I want to show you. What I want to show you here is that, okay, how the iron, okay, decreases in quantity. See, this iron has now become this much. So this is how rusting affects the quality of the iron. Okay, so in due course of time, so this cycle keeps repeating and repeating. Okay, this layer will peel off, and then a fresh layer will be exposed again, then that fresh, and then rusting will take place on the fresh layer again. It will peel off, then again the cycle keeps continuing, and finally eventually a time will come when the entire iron will disappear. Okay, the entire iron will get rusted, and finally it will be of no use. And so this is how rust, this is how corrosion destroys iron. So now you tell me, is corrosion good? Is corrosion a good thing? No, it's not. So corrosion is a bad thing, okay, because corrosion destroys iron. Okay, so we have to prevent corrosion from happening to iron. Okay, so now let's discuss the second metal, which is silver. So let's say this is silver. Okay, my favorite drawing is box. So this is silver. Let's say this is silver. Now silver reacts with oxygen. So silver, it reacts with oxygen. It reacts with oxygen plus sulfur present in the atmosphere, and then it undergoes corrosion. Okay, now when silver undergoes corrosion, a blackish coating is formed over the surface of silver. So when silver undergoes corrosion, what happens is that a blackish coating is formed. So let me make it black here. So this is the blackish coating which is formed upon the surface of silver. Remember, corrosion is a surface deterioration process. That means it attacks a surface. So this is our silver, and then a blackish coating has been deposited, has been formed over the surface of silver. So this blackish coating, this black coating which has formed over the surface of silver, this is silver sulfide. This is silver sulfide. The reddish coating which is formed over the surface of iron is called rust, whereas the blackish coating which is formed over the surface of silver is silver sulfide. Okay, so this is how silver undergoes corrosion. Silver reacts with oxygen and sulfur present in the atmosphere. It undergoes corrosion. How do we know that silver has undergone corrosion? We can know that silver has undergone corrosion because of the deposition of the blackish substance upon the surface of silver. This black coating which is formed upon the surface of silver is called silver sulfide. Now, unlike rust, this black coating does not come out, does not peel off. Understood? We know that rust, it peels off, is not, it comes out. But unlike rust, this black coating which is formed over the surface of silver does not come out. So this process is called tarnishing. So this is tarnishing. This is also called as tarnishing. So we call it as tarnishing of silver. Okay, tarnishing of silver. We don't call rusting of silver. We call it as tarnishing of silver. Why? Because this layer remains, okay, like this for a very long period of time. So this is called tarnishing of silver. I hope you got it. Okay, now let's go to the next one. There is no room here, so let me erase this, and then let's discuss the third one. The third one is copper. Let's discuss corrosion of copper. Copper. Now let's learn about the corrosion of copper. So this is copper, CuPPER. So copper, it reacts with oxygen plus moist carbon dioxide. let me draw the formula of carbon. Let me write the formula of carbon dioxide, which is CO2. So copper reacts with oxygen and moist carbon dioxide present in the atmosphere, and then it undergoes corrosion. Now, what happens when copper undergoes corrosion? So when copper undergoes corrosion, what happens is that the brown color of copper, because copper is brown in color, okay, the color of copper is brown. So the brown color of copper changes to green. So copper develops a greenish coating upon its surface. So this one, this highlight which I'm doing upon the surface of copper, this is green in color. This is the green coating which is formed upon the copper metal. Okay, this is how copper undergoes corrosion. When copper undergoes corrosion, the brown color of copper will start changing to green color. So copper gets a greenish coating upon its surface. This green coating is called copper carbonate. Is basic copper carbonate. This greenish coating which is formed upon the surface of copper is basic copper carbonate. Very, very important. You have to know the name of the coating. The name of the coating which is formed upon the surface of copper is basic copper carbonate. It is greenish in color. Okay. Then for silver, the coating is black in color. What is its name? It's silver sulfide. And for iron, it is reddish brown in color. Okay. And it's flaky in nature. What is it? It is called rust. So this is how copper undergoes corrosion. Copper, which is brown in color when it is new, when it's exposed to oxygen and moist carbon dioxide, it undergoes corrosion. And when it undergoes corrosion, the outer surface of copper starts. The outer surface of copper gets a green coating. This greenish coating, which is formed over the surface of copper, is basic copper carbonate. Now, similar to silver, this coating which is formed upon the surface of copper does not peel off, does not come out. So this stays for a very long period of time. This is called tarnishing. This is called tarnishing. So two metals, they form tarnishing. One is copper, the other is silver. Okay, and for iron it is rust. So remember, tarnishing for silver and tarnishing for copper and tarnishing for silver. All right. So this is it. Okay, my dear students, this is it. We have come to the end of the lesson. Now, before I say goodbye to you, this is not a goodbye. It's a it's not a permanent goodbye. It's a goodbye from this lesson, from this video. Okay. I have a question for you. So for which I want your participation. So kindly participate, because if you participate, it will motivate me. Okay. So I need your support. So keep supporting me. Okay. I need your support. So give me your love. Okay. Give me your love. So show your support by participating. So the question which I want to ask you today is a very easy question. Give one method to prevent rusting of iron. Kindly give your answer in the comment box. Answer in comment box. Your participation is what encourages me. Okay, your participation is what encourages me. Your comments, your appreciation, and then you telling me that you have learned from me. You know, that is the best feeling I ever get. Okay, so I will be here. I'll be doing this, but then to make it better, it all lies in your hand. Okay, so my dear students, remember yourself and share your love. Okay, be generous with your love. for yourself. Okay, so thank you all for tuning in, and I'll see you again in the next video. So until then, take good care and God bless you all.